friends, in this video we will understand subnetting in depth with examples. So let's start. So guys, let's understand subnetting in depth. So let's start with an example 10.10.10.1/24. So this is the IP address representation. So there are 4 octets, 1, 2, 3 and 4. 4 octets, and each octet represents 8 bit. So the size of an IP address is 32 bits. Correct? Now let's understand the significance of this /24, which we call as subnet mask. So /24 means the first 3 octet bits are on. Okay. So total how many bits are there in an IP address? 32. So out of 32, 24 bits are on. So if you convert this into binary, so it will be like so these 24 bits are on. Now what does this subnet mask represents? Basically IP address is made up of 2 things. Consists of 2 things, correct? What are those 2 things? Network portion and a host portion. So what does the subnet mask signify? Subnet mask signifies the network portion. Remember this. So subnet mask signifies network portion. Okay. And the octets which are having all the bits on, that means we cannot change those bits, they are constant. So the first octet is 10, so this represents 10, so this will not change. Again this will also not change, and this will also not change. So which octet can change? The last one. So we have the freedom to fiddle around with the 4th octet. Okay. So basically what we will do, we will convert or we will mask the zeros of the host portion, correct, into 1. Masking means converting zeros into 1. So the number of bits we convert, as we convert the number of bits into, or the host portion bits into 1, the number of subnets will increase, correct? So as we convert number of host portion bits into 1, number of subnets will increase. And number of hosts per subnet will decrease, right? So as if we convert 1 digit from 0 to 1, it will have 2 subnets and 128 hosts. But if we convert 2 host bits into 1, we will get 4 subnets, but the number of hosts per subnet will decrease. So basically subnetting, what do you mean by subnetting? Subnetting is increasing the number of subnets. Correct? If you want to get more number of subnets, we do subnetting. But the hosts will decrease as the number of subnets increases. Correct? Inversely proportional. So now let's convert one digit of host portion to 1. So what will happen? This will become 1. So subnet mask will become 24 plus 1 plus 1. So that will become 25. So subnet mask will be equal to 25. Correct? So now how do you calculate number of subnets? What is the formula for number of subnets? 2 raised to number of bits that we have converted, that we have masked in host portion. So here how many number of bits we have converted? Only 1. Correct? So 1. So 2 raised to 1. So that is equal to 2. So 2 subnets. So we should get 2 subnets. Now how many number of hosts? Number of hosts per subnet will be 2 raised to number of host bits left. So how many host bits left? 1, 2, 3, 4, 5, 6, 7. So 2 raised to 7, that is equal to 128. Okay. But how many number of host IPs usable per subnet will be 128 minus 2. So 2 raised to this. So this will be 2 raised to minus 2. So that will be 126. Now why we have subtracted 2? Because we have to subtract the network IP and the broadcast IP. So as now we know the size of each subnet, 128. Okay, so first subnet will start from 10.10.10.0 and it will go to 128. Sorry, 10 to 127. Correct? So this is your first subnet. Now, the second subnet will start from 10.10.128 and it will go to 255. So this is your second subnet. So each subnet has 128 IPs, but this first IP and the last, this is a network IP. Okay. This will be the broadcast IP. Similarly here this is the network IP and this is the broadcast IP. So this is how you do the subnetting. Now let's take quickly another example, a slightly complicated example. Okay, let's delete this whole portion. Next example we take is 172.16.0.0/22. Sorry, slash not 22, but just make it as 16. So your manager has given you a supernet, okay, of /16. Correct? Hold on. Option, just a second, let it be. So we have got a supernet of /16. Now the task the manager has asked you to convert this. Okay, what has happened? What went wrong? Now the task your manager has given you is to convert this /16 into /22. So you have to create more subnets. What I told, subnetting means you create more subnets. But when you create more subnets, the number of hosts per subnet will decrease. It will not remain as it was in the original subnet. So let's see, our original subnet mask is 16. So 1, 1, 1, 1. Okay. So these two octets are 16 bits /16. So what I told you in the previous example, this represents the network portion. So this is the original subnets, and this represents the host portions. So how many number of hosts were there earlier? 2 raised to 16 minus 2. Whatever answer is there, you just have to note it down using your calculator. Okay. Now you have to convert /22. Basically, we have 16 host bits as a in the network portion. Now what we have to do? We have to increase it to 22. So we have to borrow the bits from the host portion, right? Host portion. Borrow the bits from the host portion or mask the bits in the host portion. So we will mask. So if after masking, what will happen? So this will be your resultant subnet mask, correct? 22. Now, as I said, the bits, the octets or the bits which are on will remain constant. So this will remain constant, this will remain constant, and a part of this octet will remain constant, while this much part will keep changing. You are free to use those bits, correct? To create these bits are now the new host portion, correct? So now what will be our resultant subnet mask? Earlier it was, so this is equivalent to 255. This is equivalent to 255. So earlier our subnet mask, the original subnet mask was 255.255.0.0. Correct? Now after increasing to 22, so this will be 255.255.252.0. So this is 252. So this will become 252. Correct? Now we have to find out. This is a bit tricky. Earlier example was very simple. Now this is a bit tricky. This is a class B. So 172.16 will remain constant. Now we have to find out your first subnet. So first subnet, so 250 normally what is the addition of this entire thing is 256, right? 0 to 255, correct? Which is 256. So if you minus 252 from 256, it will give us 4. Basically 0 to 3. So the first subnet will go from 0.12 from 0.0 to 172.16.3.255. So this will be your first subnet. So how many number of subnets possible? 2 raised to number of bits which are on, which is 6, right? 2 raised to 5 is 32, 2 raised to 6 64 are the number of subnets. Now how many hosts per subnet? 2 raised to 8 plus 10, 10 raised to 10, that is equal to 1024, but we have to subtract minus 2 for each subnet, so total 1022, correct? 1022 usable hosts, IPs. This will be your first subnet. So second subnet will start from 172.16.4.0 and it will go to 4567, 16.7.255, right? 0, 1, 2, 3, 4, 5, 6, 7. Correct. Similarly, third subnet will start from 8.0 to 8, 9, 10, 11. So 11.255. Likewise, you have to keep using, you have to break your subnets and you can use it for your purpose. So this is what is subnetting. Okay, so you have to remember the original subnet mask. You have to remember the original network portion, then how many bits you are converting from the host. Okay, so that will give you the number of subnets and the number of hosts per subnets. Okay, and at the end you will have to write down the all the subnets. If but of course, if there are like 64 subnets, you may not have to write it down, but yeah, you have to, you should know, like if suppose if somebody asks you, gives you any IP randomly, then you should know like that IP belongs to which subnet. Correct. So that's what you have to write it down. So that's it about the subnetting. So one important question here: how the router knows the IP address belongs to which subnet? So suppose if a router gets a packet of IP 1.0 and subnet mask 24, 6 and with a subnet mask of 24. So how does the router comes to know to which subnet does this IP packet belongs to? So what it will do, you have to convert this part into binary. So how you convert 172 into binary? Let's do it. 2 8 are 16, 2 6 are 12. Resultant is, remainder is 0. 243, remainder is again 0. 221, remainder is 1. 2 tens are, remainder is 1. 2 fives are, remainder is 1. 2 twos are 4, remainder is 1. Then finally 2 ones are 2. Correct? So we have to add this. So 1 1 1 1 0 0. Then 16 will be 16. 2 8s are 16. 2 4s are 8. 2 2s are 4. 2 1 are. So 1 0 0 0. Sorry. 6 4 5 6 0 0. This will be 1. Not 6. Correct. This will be, I think, 0 0 0. So this will be, now you convert your subnet mask also in binary. And you do AND operation bit by bit. So AND operation means 1 and 0 is equal to 0. Only 1 and 1 will be equal to 1. So the resultant will be, if you do the AND operation of the IP address and the subnet mask, you will get 172.16.1.0, which is your subnet. So using AND operation between the given IP address, and the subnet mask, router comes to know, router understands the network of the IP packet. Okay, this is one of the interview questions. So that's it from my side. I hope this session is useful to understand subnetting. Kindly subscribe and like my channel. Thank you.